Section 4.2, types of chemical reactions. So we've shown how to balance a chemical reaction. Now let's go through and investigate some of the details of those different chemical reactions. You're going to need to, or you're going to be able to, at the end of this, recognize and describe the 5 basic types of chemical reactions, list and describe the driving forces for reactions in an aqueous solution. So those are the 2 skills that you'll be able to get to pay them bills. All right, synthesis reaction is the first type of reaction. Think of that word, synthesis, synthesizing, producing something. A synthesis reaction, well, it's going to start with a simple reactant or a simple reactants that combine to form a single, more complex product. So here's what we've got. Iron plus oxygen makes iron 3 oxide. This is the reaction that's taking place when something rusts, or when iron rusts. So think about this as 2 things become 1. 2 things combine to make 1 thing. That's a synthesis reaction. Okay. A decomposition reaction, decomposing, breaking down. Well, a decomposition reaction effectively is the same thing, but the opposite as a synthesis reaction. You've got 2 things that break into 1. So a decomposition reaction occurs when a single reactant breaks down into less complex products. We've got 2H2O yields 2H2 and O2. A single replacement reaction, also known as a single displacement or a displacement reaction, occurs when an element reacts with a compound. Okay, so if we look down at our example here, we've got solid zinc reacting with HCl, aqueous HCl. We're going to produce aqueous ZnCl2 and gaseous H2. Okay, so basically what we've done is we've taken this substance right here, an HCl, and subbed the Zn in for that H, and that H goes on to, as a diatomic gas, make H2. A double displacement reaction, well, we've got 2 ionic compounds that exchange ions. Okay, so if we look down at our example, we've got Ki and PbNO3. So lead nitrate, PbNO3, and potassium iodide, Ki, well, they kind of switch spots in a double displacement reaction. What's most important about this is being able to identify your ions, because remember, this is 2 ionic compounds. The way that I always like to think about a double displacement or a double replacement reaction is I think about them kind of following a model of AX, A being the K, and X being or representing the I, plus BY. B represents the cation here of lead, and Y represents the anion of nitrate. These 2 cations and anions, A is going to drop the X and pair up with the Y. So let me make sure that I'm using my symbols right. So this would, and we're going to produce BX plus AY. So we're just taking 2 ionic compounds and then switching the ions. So when previously a cation was paired up with this anion, now it's paired up with a different anion. Okay. In some cases, this produces a solid, lead iodide, making a precipitate there. And in other cases, well, there's no reaction, and so it's aqueous on both sides. We've got aqueous plus an aqueous yields a solid and an aqueous. So sometimes the subscripts might be different, or sorry, the states might be different. You might produce a liquid or something like that, which producing a liquid is something that you're going to see here. An acid-base reaction, this is also known as a neutralization reaction. This is an example of a double replacement reaction. An acid is a type of compound usually written with H at the beginning of its formula. So this guy right here, hydrochloric acid. That's going to mix up with a base. And a base is a compound that's generally written with OH at the end. NaOH is sodium hydroxide. We've got that same AX plus BY yields BX X plus AY. Now that AY, though, in this case looks a little bit different. Effectively, what it is H plus OH minus, producing HOH, also known as H2O. Okay, so this is a neutralization reaction, where an acid is neutralized by a base. Here's another example like that. Sulfuric acid, H2SO4, reacts with 2 moles of KOH to produce K2SO4 and 2H2O. A combustion reaction is a very rapid combination, is the rapid combination of a substance with oxygen. A hydrocarbon fuel, in this case, we've got C3H8 gas, reacts with O2. And a hallmark of a combustion reaction is it's going to produce CO2 and H2O. These two gases right here are going to pair up and produce, well, a gas and a liquid. Okay. Now, just so you know, these are some of my favorite reactions to balance and my favorite reactions to ask y'all to balance. So I would go ahead and anticipate a question or a balanced chemical reaction question on a exam that is a combustion reaction. All right. So those are, I believe that's all 5. I think that's all of them. Oh, good. Here we go. And here's our summary slide that shows everything that we're working on. And if you look down here at your double displacement, I use a little bit different. They use AB plus CD yields AD plus CB. Maybe, not exactly sure why. They're variables anyway, so it doesn't really matter how you define them. But anywho, we've got a synthesis reaction, A plus B yields AB. A decomposition reaction, I always like to think about these as kind of frenemies because they're the same, but they're the opposite. A plus B yields AB, AB yields A plus B. Single replacement and a double displacement or a double replacement are very similar. A plus BC yields AC plus B. AB plus CD yields AD plus CB. And, oh boy, I'm tired. Sorry, that was unprofessional, I think. A combustion reaction. We've got the combustion of a hydrocarbon, CXY, or CXHY plus O2 yields CO2 and H2O. Now, identify all of these different types. Go ahead and pause the video if you want to do this yourself. Okay, now that they're gone, we have 2 things, this and this, combining to form one thing. So this is a synthesis. In this case, we've got, well, let's see, that's an aqueous substance making a solid, another aqueous substance. AX, BY. Whenever I'm looking at A, X, and B, and Y, what I'm seeing, what I'm pinpointing are ions, polyatomic ions and monatomic anions, or monatomic ions. I'm producing here BX and AY. This is a double replacement. Then C, well, we're going from one thing to 2 things. So this is a decomposition. And then the last one, we've got, well, I'm just going to pick out CO2 and H2O as my products. And I'm going to hedge my bets that that's a combustion reaction. And it is. We've got a hydrocarbon reacting with O2 to produce CO2 and H2O. Okay, now that's all of your different types of reactions. What we want to go into now is what are the driving forces for those reactions in an aqueous solution? Reactions occur spontaneously due to a combination of changes in heat energy, also known as enthalpy, and randomness, also known as entropy, which are discussed in future chapters. So we'll get into those details and what those different things mean later on. Spontaneous reactions follow typical patterns classified by their driving force. Driving forces are associated with the formation of stable, lower energy products. Okay, so our aim is to produce something that is stable and lower energy. So our driving forces and different types of reactions or different reaction types. Double replacement reactions that form lower energy solid ionic compounds are called precipitation reactions. The formation of the solid, or known as your precipitate, is the driving force of that reaction. Neutralization is the driving force for an acid-base reaction that produces a salt and water. Single replacement synthesis and decomposition reactions transfer electrons to form lower energy products. This driving force is known as oxidation reduction. Okay, so here's kind of your associations. I want you to think of the first association as double replacement, precipitation. Neutralization, acid base. Then single replacement, synthesis, decomposition, oxidation reduction. Okay, so if you can associate those terms and concepts, you're going to be in good shape for all these definitions. So when we look at this particular reaction, this first one up top, what do we have? We've got a synthesis reaction. This is a great example of a ox reduction. Our double displacement reaction here, option B. Well, that is going to be a precipitation reaction. So I'm going to write pt2. And then this last one is a decomposition. A decomposition reaction is, it is a precipitation reaction. Yeah, pp2. Option C here is calcium carbonate breaks down into calcium oxide and carbon dioxide, and that is a good example of another ox reduction reaction. All right, well, I hope this is helpful. This is a little bit of a longer video, but we'll forge ahead. All right, everybody. See you in the next video.